Ladies and gentlemen, dear colleagues, thank you for attending at this late hour of the AES Convention second day. This computer-generated voice came from an assistive software for blind people, a so-called screen reader.
Good afternoon and welcome to the presentation of my long-term audio project with visually impaired people. Due to the short given time about this very wide topic, I will have to focus on given possibilities and the results. Please refer to my paper on the AES Presenters Hub for more scientific background information, or contact me after the presentation in front of the stage where I offer handouts and show some exemplary devices. In my prior role as educator of voluntary radio producers for community radios in Austria and Germany, I became aware of the disadvantages and barriers visually impaired people face in a studio and the lack of education and job opportunities after I met blind students taking part in inclusive workshops for radio journalism in 2004. As you may be aware, many blind people own outstanding acoustic capabilities to compensate missing eyesight. Moving indoors or outdoors, many orientate in the spatial environment bat-like by emitting lip pops or clicks with the tongue to scan the surrounding acoustically and precisely localize obstacles even in noisy environments. Audio engineers know about the precision of the human ear of stunning 0.03 milliseconds, which compares to only 1 centimeter of audio runtime. We identify tiniest audible events by analyzing interaural time and level differences, spectral characteristics and phase-related informations. Please just imagine if you were not sighted at work in the studio, not seeing the view meters or displays and other visual elements or controls. Every blind person with healthy ears enjoys some kind of music, listens to radio plays, audiobooks and movies with audio transcription. Many play musical instruments or even compose music, write songs or stories which could become published as records, radio plays or audiobooks. Considering these facts, many are predestined to work in any field of audio production, in particular musicians with technical ambitions, authors or presenters. But almost none produce and publish their own work to make a living and become independent from social welfare and other dependencies. According to the World Blind Union, more than 75% visually impaired people are unemployed worldwide, because they do not have much of a choice to gain a profession at all. That is what my work is aiming at, finding solutions and methods to overcome at least some of the disadvantages to get the most talented ones into the studio doing their job. Of course, blind people require certain assistive tools, teaching methods and aids. So what are the solutions? The inventor Ray Kurzweil was the first who took advantage of developing a text-reading machine in 1978, which would allow blind people to understand written text by having a computer to read it to them aloud. The computer voice you heard in the beginning was generated by such an assistive software. Together with Stevie Wonder, Mr. Kurzweil improved his screen reader and developed also well-known high-end musical keyboards and synthesizers. With upcoming personal computers, a piezoelectric-driven braille display was established, working simultaneous with the screen reader. Nowadays, assistive technology has reached a point that enables blind people to fully participate in education, the internet and networking almost like sighted people do. So why should they not take part in the fast-growing multimedia industry? Apple Computer's OS X is the first operating system that includes a free screen reader by default since 2011. And besides some commercial products, there is the well-working open-source screen reader named NVDA, Non-Visual Desktop Access, programmed by those sympathetic Australians. Braille displays enable blind people almost full access to all sorts of computer appliances and software. The shown braille display is a portable version with 40 letters in a row, which equals half a line of black printed 12-sized font. Due to the fact of the very complex braille components and the relatively low number in production, it is very costly. We talk about approximately $5,000, depending on the manufacturer. Most Western social welfare systems cover these costs, but not so-called third world countries. My very first moment I became aware of special needs was when I had the great honor to work with one of the greatest blind musicians in 1996 in my hometown Salzburg. Ray Charles and his band played a concert accompanied by the Mozarteum Symphonic Orchestra at Salzburg Festival Hall, where I mixed the monitors and supported Ray setting up his instruments on stage. The controls on his keyboards were covered with braille lettering, which was my very first touch of tactile writing. Stunning how someone could possibly read this. Labeling technical equipment with embossing tape and a hand printer as shown is the affordable and effective way to make technical equipment accessible. Braille labels unfortunately need double the space per letter than black printed letters do, so I preferably use transparent embossing tape to not cover black print. You may ask why I show you such old-fashioned analog mixing desks. I do because analog mixers have every available control, button and knob in instant reach, what eases learning, understanding and first handling for blind users. Digital mixers are simply too optical and virtual oriented, impossible to be handled by non-sighted. But virtual mixers of software with MIDI capability can be hardware controlled by MIDI controllers. The most important thing in audio work is keeping levels correct during recording, mixing or live broadcasts. This requires being able to read audio levels at all time. So how to get over this seemingly so simple task? There are only two ways of parameter output readable for a blind person: tactile and audible. My advantage as electronic audio and broadcast engineer led me towards the basic principles of a possible technical solution shown. On that basis, I began to experiment on the breadboard. Thanks to the rise of affordable embedded computers, I could develop a digital device with braille display and speech output named Studioguard Nano. Assistive technology for visually impaired sound producers. A short introduction. Studioguard Nano supports blind producers while recording and editing audio. Studioguard Nano analyzes the audio signal, translates relevant values in electronic braille letters and generates bilingual speech warnings audible only in the user's headphones. Studioguard Nano is a handy desktop unit about third the size of a typical PC keyboard. The front of the unit owns a headphone socket and the volume knob. On the back sits the on-off switch, a single input connector for easy installation and a gain pot for adjustment. The slightly angled surface contains a braille display, two faders for monitor control and two push buttons for braille mode and voice mode. The faders level the mix you hear in the headphones. The alarm fader controls volume of speech messages. Phone's fader levels monitoring from your mixing desk. PFL, Q or solo functions are available as usual. The picture shows my home studio with Studioguard Nano, which gets activated now. After short boot-up routines, the braille display shows OK, and a voice in the headphones confirms being ready for use.
Hello, Studioguard ready.
BrailleGuard is in text mode by default, showing simple abbreviations like OK, high, low, reporting the audio signal's average level.
Braille graphics.
Pushing the Braille mode button changes the display from text mode to graphic mode, which is similar to an optical view meter. This mode is also suitable for users without Braille knowledge.
Braille numeric.
Pushing Braille mode again, the display turns to numeric mode, showing the level in numeric decibel values.
Deutsch.
By pushing voice mode, the language changes from default English to German. Another push mutes speech. Since 4 years, several Studioguard Nano are permanently in use, supporting blind users who were instantly more sovereign during broadcasts and recording sessions. Another important task was to ease navigation and control within editor software. Blind cannot use a computer mouse, so most functions require the use of shortcuts. Multiple keystrokes are tricky and need both hands, so I programmed a shortcut controller for access and convenience of pressing just one key. 2 foot switches allow musicians control of record and playback functions to have their hands free during recording sessions. Studioguard keys dimensions are identical to Studioguard Nano. For first lectures, I normally use the freeware editor Audacity, which is sort of suitable for beginners, but does unfortunately not support MIDI, what actually was the reason for developing Studioguard Key in the first place. Just recently, 2 well-known major companies, Avid of Pro Tools and Magix with Sequoia and Samplitude, offer specialized plugins for blind users in some of their products. This is absolutely the right move into the right direction and surely is highly appreciated by those affected. But for absolute beginners, a software reduced to the most needed functions would be desirable, because I experienced that newcomers often are confused and overtaxed by the vast amount of functions in advanced DAW software. I drew a simple sketch of what I imagine, which is sort of comparable to Cubase 1.1 on my Atari ages ago. Beside those assistive tools, I designed teaching aids with haptic printings for those who really want to learn audio engineering from scratch. Therefore, it is necessary to understand theory and basic physical principles of room acoustics, waveforms, envelopes, etc., which often need to be displayed graphical for better comprehension by the trainees. Another important lecture is teaching the participants how to secure and safe handle all sorts of equipment like microphone stands, microphones of any shape and appliance, DI boxes, correctly recognizing cables, plugs and sockets for different applications in the studio or on stage. Coming to an end, I want to say that Ray Charles and Stevie Wonder are only 2 of many blind artists who prove that it's possible to have a career on stage and in the studio. Not everybody will become as famous, but never say never. And that is what I cling on, to spread hope and self-confidence, empowering and supporting talented people, raising opportunities and offering solutions for given barriers and overcome the preconception of disability in the public domain. Finally, I'm proud to present some of my trainees to you. "32 visually impaired musicians, ongoing presenters, producers, authors, narrators and entertainers from Austria and Germany, partly awarded and on duty." Thanks kindly for your attention.